bottom of page 2 from section 9.2, we're going to take our skills so far and put them into one problem. So if you look back on the first page, we were multiplying radicals, kind of like what you're seeing here on this bottom part of the notes. And then on the top part of this page 2, we were learning how to simplify what was inside a radical. So what we're going to do now is we're going to combine those two pieces. We're going to multiply and then, if possible, simplify. So we're going to mush them together first and then split them out into as simplified pieces as possible. So the multiplication part should be fairly easy at this point. Just make one big radical. 20 times 5 is 100. X times x is x squared. And then you look to see if you have roots that you can find. Now we're still dealing with square roots here because you don't see a number, so you assume it's a 2. It's a square root. And again, these can be, if it helps you, split these apart so you can see it dealing with the numbers and the variables separately. So this becomes radical 100 and radical x squared. Or you could say it as square root 100, square root x squared. And 100 is a perfect square, so it's 10 times 10. So your radical 100 just equals 10. And your radical x squared, that's the definition of undoing the x squared, is taking the square root of it. So that's just x. So x times x gives you x squared, so you're just going to get plain old x. Nothing is left on the inside. And if you think about it, that matches our rule too. You could have taken the 2, the exponent, divided by the index 2. That would go in once with a remainder of 0. So the exponent of 1 would be on the outside here, 10x to the 1. A remainder of 0, x to the 0, that would just be 1. The 1 on the inside of a radical, square root of 1 is 1. So that's why nothing stays on the inside. Your answer is just 10x there. Okay, so we're multiplying and then simplifying. So it feels like we're smushing together and then pulling them back apart. The difference is when we pull them back apart, we're looking for those perfect squares, because we're looking at square roots. In just a little bit, we'll up the roots and do that. Pardon me, the phone's ringing, so I'll make a third section of these notes in just a moment.